when we're talking about pipeline architectures, could you please share with us high-level data analytics pipeline architecture? How does it look like, and what are the different components, maybe?
A typical architecture would consist of 4 stages. Number 1 is collecting the data. So we have sources, and then we want to fetch all the data from those sources into my store, right? While fetching the data, there might be use cases that I need to process the data. For example, there are tools which provide me windowing capabilities. Every 5 minutes, I would like to do an aggregation of the game scores, right? So this is one use case.
Yeah.
Or I would like to remove or join a couple of columns to make a unique ID while the data is coming in real time, right? That's another use case which is very common, right?
Okay.
I may like to trim some of the, let's say, I would like to split first name and last name into 2 different columns, right? Or I would like to change. Some people use spelling of Delhi as DELI, DELHI, or there might be other mistakes. So I would like to correct it as the data is coming in to improve the quality of that database so that my models are good, right? So collection, processing, storing, and then using it for AI ML, my business intelligence, visualization using Data Studio or Power BI or Tableau, and other tools like Jupyter Notebooks and all to write my my AI ML models, right? So these are the 4 stages which we have. And then there are multiple tools which we use. For example, if we speak of bringing in real-time data, Kafka is one of the most commonly adopted tool which we have for real-time data. It's a write-ahead logging based messaging tool. So you have a publisher and a subscriber model, and you bring in the data in real time, what my customers are doing on my websites, which links they are clicking, which offers they are subscribing to. So all that information in real time can be captured using Kafka, right? There are tools like open, and all these tools which I'm talking about are open source. We'll discuss, whether startup should go with open source or managed services later. To bring in real-time data from relational databases. For example, I want to move my data from MySQL into a data warehouse. We have open source tools like Debezium. We call it as change data capture. As and when data is getting written into MySQL or Postgres or any relational database, Debezium just fetches that data, and it has a Kafka connector. It can write it into Kafka, and then we can move it into our data warehouse, right? To move the batch data, we may have different cloud APIs. I can install, Google Cloud or AWS SDKs on my VMs, and then do a bulk copy. We can even use other SCP and FTP mechanisms to move the files for the batch processing, right? So and then there are the latest trend is to open up APIs, and we can even do API calls to fetch the data from some of these sources. So this is basically the ingestion part. How do I bring in the real time as well as batch data into my stores? If we speak of processing, there are open source tools like Apache Beam, using which I can do transformations on both real time as well as batch data. People might have use Hadoop there to do batch processing, or Spark for real time. There are other tools like Apache Airbyte, or even CDAP, which is again a platform to do data integration. So all these are open source tools. Then we have stores like we have BigQuery in Google, which is very common data warehouse. It's serverless. You just dump the data, and whenever you need, you query it. You only pay for the the query which you do. In open source, we have Apache Druid, ClickHouse, Other names which you might have heard of is, these are not open source, but Snowflake and Amazon Redshift. So these are some of the choices for the data warehouses.
Okay.
And finally, we have our once the data is there in a warehouse, I will use it for my machine learning, predictions, BI tools. I can even fetch the data into sheets, and then my team members who are very well versed with sheets, Excel sheets, they can do the analytics in sheets, and there are various other sources. So this is how, generally based on use cases, we select the tools, and these are mostly DIY tools, do it yourself, not managed services. Though we have managed services available on cloud platforms, for example, for Kafka, we have Confluent Kafka, which is a managed service. You don't have to configure it, bother about the underlying infrastructure, security, and all those things. That's taken care of, right? For Hadoop, we have Dataproc. For Apache Beam, we have Dataflow. So there are managed services for these open source as well, which actually prevents you from getting logged in into any particular cloud platform. You can do it hybrid, on premise, on any cloud, and so on.
Okay. Makes sense, Prashant. So you touched upon batch processing, stream processing, right? So it's a follow-up question on that. So when in what scenarios would we use either one of them? So when stream processing, batch processing, and I was reading up, and there is something called micro batch processing as well now that's coming up, which is not really real time, but still almost real time, right? So when do you really use all these?
Okay, so the use of these from stream processing and batch processing would generally depend on the industry you are in. For example, and some of these use cases may be common because most of the businesses would have customers, and they would like to understand their customer well, so that they can get more business out of them, right? So
True.
wherever we have B2C sort of use cases, customer 360, is one of the use case where we would like to get deeper into what's the behavior of my customer, what are they doing on my website, on my apps. So we call it as clickstream analytics, right? So it's a real time information on what a customer is doing on a website,
Okay.
and based on that we do real time advertising or offers, and so on.
Okay.
Another real time use case very well used in the BFSI or the financial sector is real time fraud detection. So they, based on the historical transactions, they would immediately predict whether this transaction is fraud or not, right? There are log analytics which are done, which most of us as engineers would have used if we are using cloud platform. In real time, I can see how my machines are behaving, where the CPU is up, where it is down. That's because the logs are coming in real time into my software, which is the log analytics software, and I get a dashboard on all the analytics which is happening. A lot of manufacturing, customers, especially these electric vehicles, right? They have a lot of sensors placed into their vehicles, and while driving, the data comes in real time from those sensors, and I'm able to see my, how much of battery is left, how much of tire pressure, how is my engine doing, and all those things in real time. Mobile towers is another example who use a lot of these sensors. And then security solutions, so another very critical example of real time, because if I miss that particular point in time, if fraud may happen or
True.
somebody would hack my system. So
Correct.
on cloud, generally you will see solutions like security command center and all those things, where all the logs and auditing flows into these services, and in real time they will project whether there is any, let's say, crypto mining attack happening or DDoS happening, and then the mitigation is done based on that. In terms of batch processing, I think it's mostly related to bulk data. I may have a lot of files coming in during the day, and during the night a batch starts, and either it could be searching for particular patterns in those files. And you might have heard about banking reconciliations, which used to happen during nights, bill generations. So these are all batch processing examples.
Okay,
If you
makes sense.
remember, earlier, if we used to transfer money, it would take 24 hours even through the website before this NEFT and other things were invented. That's because a flag would have been set as yes for the amount to be transferred, and after 8 hours or so a batch will click in and it will do all the money transfers, reading from the table wherever that flag is set. So these
Makes sense.
are some of the examples of batch processing.
Okay, pretty insightful, Prashant, because most of the time we have options, a lot of options available. Then you're thinking about, what would really make sense in my architecture, right? And the kind of solution that I'm trying to provide. So thank you so much on that. Coming to data storage, so you talked about different tools. Now we have transactional data. We have now when you talk about analytical data, which would be like maybe batch processed. Now, in what scenarios would you look at the storage? Like when I look at OLTP or OLAP, data warehouse or data lake, right? Uh, what are the scenarios, and when should I really go ahead and choose which one?
Sure. This is very critical question, especially for startups, because uh, I have spoken to organizations where they started using, since they were growing, right? They started using MySQL as a transactional database, which was fine. It is meant to run transactional workloads, but then they also hooked into MySQL their BI tools, BI engines, which had complex queries, right? And that's when even the transactional workloads started suffering, because the processing of those complex SQLs would take most of the resources, right?
Okay.
So it's important to understand. It's okay if we are very small, and then we have budget limitations or resource limitations. It's okay to use a single monolithic database for both the use cases. Then now we have read replicas and all those things on cloud to support the read workloads. But as we grow, as the data grows, OLAP storage or OLAP data stores would have different mechanisms to handle that scale of data, especially if we
Okay.
speak of several terabytes or petabytes. We need to partition the data internally. There are internal indexes which are maintained, and partition pruning is done so that I'm reading less data. Uh, I'm touching storage very less. Most of the thing comes out of buffers and caches, and even the storage is columnar, so that I generally in reporting or in complex warehousing queries, we use very less columns in select clause. Never use a star, because the data size is huge, and the columns, since data warehouse should have good variety, we have a lot of columns, and if we do a select star, it would actually have a lot of negative impact, performance impact on the system. So the columnar engine is meant for, if we have less columns in my select clause, it only hits the blocks where that particular column data is stored. It really
Okay.
helps reducing the I/O and improving the performance several times. So the architectures are different for OLTP and OLAP. As we grow, we should ideally move our OLAP and reporting and analytics workloads to data warehouses, which I mentioned, right? BigQuery, Snowflake, Redshift. These are all data warehouses which have a different mechanism to handle those sort of